Hello everyone. In this third part of our tutorial series, we'll try to draw up some detention ponds and run some analysis inside Autodesk SSA. And if you don't know what Autodesk SSA is, it's an extension from Civil 3D that you have to download separately. And basically it runs simulation for water, rain, and like underground pipe systems basically. So to start off, I think we'll start by drawing just a sketch of our detention pond. I'll go to layer properties and create a new layer. I'll just right click and create new layer, and I'll just name it pond. Okay, I will set it as current, and I'll just start drawing a pond. I'll use the spline fit here in the draw tab, and then I'll just start clicking on the surface. I'll click on this green area inside Swimbin, the existing green area, and we'll use that area to make like a quick and dirty pond. Let's do that. Click on enter, and just move it a bit like that. Yep. I think that works. So that's our pond. Okay. And right now we can open SSA and start completing our analysis. So inside SSA, before we do anything, there's a few things that we'll need to set up. First, go to Import and then Project Options. Here we have to set up how we want to simulate, like what is the simulation method. So we'll use EPA as WMM. This is pretty standard simulation method that is used across the world. SSA is set up more catered towards US users, so a lot of the others simulation methods will be catered to the US, so just use EPA to get a good results in Australia. And also we have to choose a infiltration method, so we'll just choose Hawthorne, so we could adjust how we want the infiltration to happen, and just click on OK. Next thing, we have to set up how long we want our simulation to be. So we go to Analysis and Analysis Options. Over here on End Analysis, we don't have to worry about the date. I'll just click 3 days from today. So the analysis duration will be 3 days. So what will happen is, so the rain will continue for 1 whole day, and for the rest 2 days, we'll see how the water affects. So the first thing we'll need to do to start our simulation is set up the rain. So up here, we go to rain gauge, and then just click anywhere on the screen. So you want to double click on the rain gauge. In time series, click on the 3 dots, go to add, and then go to rainfall designer. And here you can see states and countries. Because SSA is more catered towards US users, so here you can see all the states in the US, but because we're in Melbourne, we'll just leave it as none. And in unit intensity, here is a lot of like rainfall patterns, but those are all in the US, like Florida. You can see other types of rainfall patterns. So what we could do there is we could use constant intensity to get like more of a default simulation. Then we have to know what's the rain depth. So to do that, we have to go to this website. rainfall design data 2016. I'll go to start a new search, select on map, and here I already selected the point in Swinburne. So here's a map of Melbourne. You just have to zoom into where you want to select and just go to submit. And in here you can see the probability of rain and with the duration of the selected point. So for Swinburne, we want to see the 1%. The 1% means this rainfall is possible to happen once every 100 years. And we want to look for the 24 hours duration. And here we can see in Swinburne, 1 in 100 years, they will have a rainfall of 130 millimeters. And this is like an extreme scenario, and we want to use that in our simulation. So we go back to SSA, and in rain depth, we'll just key in 130. And for the return period, this is nothing to do with the rain simulation itself. It's just to let us know that we're simulating for 1 in 100 years. So we'll just click on OK for that, and we'll just click on close. So the next thing we need to do is to create a subbasing. Just go to the top and click on add subbasing. Just draw a rectangle like that, double click to close it. And we want to double click the middle of the subbasing. And first we connect the rain gauge to the rain gauge we just created. And we have to fill up some information for our subbasing. First it's asking for the area. So we go back to our Civil 3D, click on the catchment area that we created in the previous video, right click properties, and we check out how big it is. Just give me 1 second. Click on that, properties, and over here you can see the area is 7.24 hectares. We go back, we'll just type in 7.24. And the next thing we have to figure out is the maximum infiltration rate and a minimum infiltration rate. Here, if you go to floor properties and click on the 3 dots over here, you can see a list of suggestions on infiltration rates and what you should put. But for now, let's just start by simulating the whole school is just concrete and with no infiltration. And we'll close that. Next we have to connect our detention pond. So we go up here to add storage node, add a storage node, double click on the storage node, and first we have to fill out the constant area. So let's go back to Civil 3D again and just look at our detention pond that we made, which is over here. Right click, properties, and see the area. The area is 2046 meters square. So we just type that amount. 2046 meters square. And for the maximum elevation, that is how deep you want your detention pond to be. For me, I want it pretty shallow, so I'll just put like 0.5 millimeters, 0.5 meters. And for the type, you just want to choose functional for now. And for exfiltration, this lets you decide how much water will come out of your pond. So if you use at all um, elevations and put in amounts, you could simulate your pond infiltrating water. So, but now, for now, we'll just leave it as no infiltration. We'll come back and change it maybe later. So we'll just close it for now. And next we have to add a outfall. So go up here, add outfall, just click anywhere on the canvas, and we need to connect everything together. So first, connect the subbasing to the storage node. And next we just want to add a where, so we could let the simulation run. We just click on add where, click on the storage node, click somewhere in the middle, and click on the outfall. For the where, we just want to set the creased elevation, the elevation of the where, something really high, so it doesn't affect simulation, doesn't affect how our pond reacts to the rain. We'll just add that, close, and then on the top here we could click on run simulation. Just click on X, and here you can see the storage node is blue, and the red text means that there's flooding. So you can see the max water depth reaches up to 0.5 meters, which is the depth of our pond, and then the total flooding and the flood duration of the flood. If you close that, if we right click on it, and you could go to display time series plot, you can see the detailed data of what is actually happening. So here you can see the inflow. We will just close that. Let's check out like the volume of our detention pond. So click down, storage node. So you can see the water just kind of increases, and then it's filled up all the way to the top of our detention pond. So right now, let's make some changes to our pond and our surface. So the first thing we need to do is I want to add another subbasing. So right now, we're simulating that the whole subbasing is just concrete with no infiltration. Let's add another one and make it like maybe 1/3 of the school is green. So we'll add another subbasing here. So right now our total area is 7.24 hectares. 7.24, that's divided by 3, so 241. And the subbasing 2 we created, let's make it as 2.41 hectares, and that's minus 2.41 from the whole area, so that will be 7.24 minus 2.41, so that will be 4.83. And we'll give it a name so we don't get confused. So in subbasing 1, we'll give it a name solid, and in subbasing 2, we'll give it a name of green. So basically we have 2/3 of the area of our site is solid with no infiltration, and we'll make 1/3 of our site a green area with soil that has infiltration. So we'll set up our infiltration rate. So go to flow properties, and then click on the 3 dots. So let me see. We'll have dry soil, and we'll use loam soils with dense vegetation. So this one will be the one we use, dry soil with dense vegetation, loam soil, which has 152 max infiltration, 152. That's good. And then let's scroll down and see when it's moist with dense vegetation, when it is moist. Loam soil, the infiltration rate will drop down to 64. So the minimal infiltration rate will use 64. So this is the infiltration rate, is when the ground is all soaked up in water and it can't really infiltrate at its max speed. So close it. Now we have two sub-basins. One is the concrete solid and one is the green. We want to connect those two both to the our detention pond. Connect. And then let's run the simulation again and see how we go. You can see right now here, there's still plenty of flood. So it's not good. But if you remember, just now we have a total volume of 800, and now it already dropped down to around 580. That is because we had more areas of green area, and which makes it better for our storage node to handle. Next thing we'll do to stop the flood is maybe we'll try increasing the size of our detention pond. So let's say let's add another detention pond then. I think that would be a good idea. Add-on spline. Let's say we want to demolish the car park area here, and we want to make a huge detention pond here as well. Let's go like this. And then let's add one more detention pond. Let me see, where should we add it? Maybe we add it here, the open area. On the other side of Wakefield Street, let's add another detention pond, like that. Enter. Let's adjust it a bit. Okay, so right now we have 3 more detention ponds. Let's calculate their area. So type in area, enter. We go to add area, click on objects, and click on the 3 ponds that we created. Enter. So the total area now comes to 5,957. So we just change that to 5,957 and hit close. Close. And then let's run the simulation again. Click on OK. Let's see. So right now you can see there's still a bit of flood. It dropped down to 387 right now, because we added the area of detention ponds. So right now, our site is still flooding, our detention pond is still flooding. We could also add a little bit of infiltration for our pond. So let's just give it a very small number, like 0.1 cms, and see how that will help our pond. So we'll just close and run the simulation again. Close that. And now we could see it didn't flood it. So the total flood time becomes 0, and the max water depth goes to 0.47, just right below our elevation of 0.5. And close that, and we could right click on the storage node and go to this display time series plot and see how it goes. So for our sub-basing, we could look at the runoff. This is the runoff of the green area in blue. And when we open the solid, you can see the runoff area is so much higher. This is the runoff area with no vegetations and no soil at all, just concrete. This is how much of a runoff it is. So it's very important to have like green infrastructure to help with making it like a smart city. Next, we could take a look at the volume and see how the water leaves the detention pond. So you can see here the time, the water spikes up, and then as the water infiltrates and the water stops, slowly the water runs away. So that's all. That's how you draw up a sketch detention pond in Civil 3D, and you put the data inside Autodesk SSA and simulate if your detention pond helps with your site and stops the site from flooding. Thank you.